Hi and welcome to this video where we're going to look at the hydrolysis reactions that esters and amides in particular undergo. So we're going to look at what the definition of that is, what conditions are required for hydrolysis, and the products of these reactions. Now, hydrolysis reactions are absolutely key at this level. Hydrolysis reactions and condensation reactions always appear in your NCEA exams. If there's one thing that I can promise you, it's that there will be a hydrolysis question and there'll be a condensation question. Okay, so let's have a look at a definition first. Hydrolysis is a reaction that uses water to break a larger molecule into two or more smaller molecules. Now, so this is basically the reverse of a condensation reaction. So if you think that an ester is formed from a carboxylic acid and an alcohol coming together, the hydrolysis reaction basically just adds the water back in and breaks it up again. So what does that really look like? Oh, jumped too far. So with an ester, when we hydrolyze it, we get the alcohol and the carboxylic acid back again. It never goes back to an acyl chloride, okay? Always goes back to the alcohol and the carboxylic acid. Now, in acidic conditions, you get exactly that, the alcohol and the carboxylic acid, just as you wanted. In basic conditions, because you've got base, OH minus, present, then the carboxylic acid will react with the base and will form a carboxylate anion, so it will donate its proton effectively. Alright, so let's have a look and see what these actually look like in practice. Okay, so here we have a generic ester. I haven't got anything attached to these carbons because it could be anything and it really doesn't matter. So if we're doing this in acidic conditions, first off, we have water and H+. So water, remember, is H+ and OH-. So what happens? Well, let's see. First, what happens is that the molecule splits between the O and the carbonyl group, and then we add H onto one side and OH onto the other. So it looks like this. We've broken it up, we've added OH onto the other, and hopefully you can see there that what you really have is now an alcohol and a carboxylic acid. It doesn't matter what the chain looked like to start with. Okay, but I'll show you with a real example in a sec. Okay, so here we have our ester, ethyl propanoate. And when we hydrolyze this in acidic conditions, all we're going to do is break it up and then add water into it. So we're going to break it just this way between here. All right, break it there, and then we're going to add H+ onto one side or H onto one side and OH onto the other. I'll show you in 2 secs what that's going to look like. Okay, so here we have it. We've got our ethyl propanoate. We've broken it in the middle between the two O's basically. We've added an OH onto the carboxylic acid, and an H onto the ethanol, and so our ethyl propanoate has now become propanoic acid and ethanol. Now, how would this change in basic conditions? Well, there's only one little change that's going to happen, so just bear with me for 2 secs. Okay, so if we have OH- instead of H+, what's going to happen is that the carboxylic acid here is going to react with the OH- here. Okay, so acid-base reaction. So the propanoic acid is going to lose a proton, forming the propanoate ion. That's all. Now, if you know that it's sodium hydroxide, then you could call it sodium propanoate, would be your other product. But if you don't know, propanoate is fine. In fact, it's always going to be fine. So to recap, with esters, what we have is we get the alcohol and the carboxylic acid back. In acidic conditions, that's all you stay with. In basic conditions, the carboxylic acid is going to react with the base to form the carboxylate anion. Okay, so you're either going to have alcohol and acid or alcohol and carboxylate anion as your products for the hydrolysis of an ester. Now, amides are similar, not similar, kind of. Okay, so with an amide, we get a similar sort of thing. So you get a carboxylic acid and an amine or ammonia, depending on whether you've got a primary or a secondary or a tertiary amide. Now, in this case, the carboxylic acid is acidic, the amine is a base. So whether you're doing your hydrolysis in acidic conditions or in basic conditions, you still get that protonation or deprotonation going on. Okay, now that sounds confusing, so please let me show you what I'm talking about. Okay, so I'm showing you this example using a generic secondary amide because that's what you're more likely to see. So the first thing that you're going to do, exactly like you would with an ester, is you're going to split the molecule and add H or OH. Alright, so now where do you split it? Well, you split it, I'm going backwards, right here, between the C and the N. Okay? Right here. Now once you've split it, you add H onto the N and you add OH onto the carboxylate group. Okay, so that's going to look, so we've got, and so we've got our two products, here we go, sorry, okay, our carboxylic acid and our amine. Now, this is in acidic conditions, so an amine is a base, it's going to react with an acid. How does a base react with an acid? Well, it reacts with an acid to accept a proton. Where does that proton go? It goes onto the nitrogen, just like so. Okay, so in acidic conditions, you get a carboxylic acid and you get an alkyl ammonium ion, or just ammonium if you've got a primary amide, but normally they give you a secondary amide. Okay, so that's in acidic conditions. Well, how does it change in basic conditions? In basic conditions, the first step is still the same. You split the molecule in half into your carboxylic acid and your amine, just as so. Right, so just as so, we're splitting the molecule up. This time we're in basic conditions, so the base, of course, is going to react with our acid. It's going to react with our acid by making the acid donate a proton to form a carboxylate anion. So whether you've got acidic or basic conditions, you're always going to get an ion of one sort or the other when you have an amide. Okay. Amides can be slightly more confusing, and that is one of the reasons why NCEA exams love to include hydrolysis of amides. Just have a look through the last few years' exam questions if you don't believe me. So please work on the ideas associated with this hydrolysis. We'll also revisit hydrolysis when we look at condensation polymers and the hydrolysis of condensation polymers. Basically, hydrolysis means to split something up by adding water, and that is the key thing to remember. You just need to remember you're splitting it up by adding water. You're reversing the formation reactions in effect. Okay, I hope that made a reasonable amount of sense to people. I'll see you in the next video. Thanks for your time.